uses. Here we didn't consider the digested one. Okay. That is scenario 1. Scenario 2, we adopted same way like rice straw, collection, baling, transportation, size reduction. Where here we consider pelletization. If you pellet that, then we go for the transportation, mixing, and then feed it to biogas unit. Okay, here in this second scenario, we consider pelletization. Third scenario, we adopted pre-treatment also before pelletization. So pre-treatment followed by pelletization. So this is 3 different scenario we considered for life cycle analysis, and this is the analysis for the scenario 1, business usual, where you can see the global warming. This is for the pelletization one. This is for pelletization and pre-treatment. So since final global warming potential we found. So scenario 1 is generating good amount of global warming, and scenario 2 and scenario 3 almost is same. There is no issue. So benefit would be more significant if you consider bulk density of pellets for longer distance, more than 50 kilometer. Benefits would be more significant, and impact of scenario 3, scenario 2 economically, these routes may be more beneficial due to the much higher biogas yield. We have considered the sensitivity analysis also. So this is the final findings from this entire study. Like India have high biogas potential, and adoption of biogas technology is hindered by many different factors. So measures are like a very high cost, lack of financial support, and especially variation of the feed. And I think pelletization or pre-treatment along with pelletization is very good for the, especially for agriculture residue, if you consider. So this is how I think few different area we're working in our group. Our group named as an waste management group, WMRG. We did successful trial of different waste material. Like this presentation was mostly on the agriculture residue, but in our laboratory we worked on food waste, water, different waste material, even terrestrial weed like this Congress grass, so, Parthenium histoprocess. It's very difficult to create biogas out of that. Even from industrial waste, pulp and paper mill, even for sludge also from the paper mill we consider. And different livestock also we have considered which one is best, because we are in Northeast, and pig dung is very common here. Swine wastewater or swine sludge is very common here to find. That also we considered for inoculum. And different reactors we have designed. Few designs like this anaerobic auger plug flow reactor, single phase continuous anaerobic reactor, and biphase continuous anaerobic reactor we have designed in the laboratory scale. And the one very special reactor we have designed, anaerobic biphase baffle reactor, ABBR, the first photograph. So this one is a size of 0.7 meter cube. So in this 0.7 meter cube, the gas storage is 0.5 meter cube. We can feed around 20 kg, 20 to 25 kg of waste material, the gas production. Then this is the current ABBR reactor is operating in our laboratory. Is a size is 10 meter cube, where methane production is close to 70%, very low HRT, 18 to 20 days. Commercially available reactor have HRT goes to 40 days, 45 days, whereas our design is as 18 to 20 days. And if you use food waste, cooked food waste, especially kitchen waste, the HRT goes to just 12 days or 15 days. So here idea behind the kitchen that HRT, because in the small reactor you can feed good amount of waste. So if you take 1 meter cube of 1 meter cube size ABBR, you'll be able to feed around 20-25 kg of waste. So 20-25 kg means almost 20 families will generate about that. Is it just a small reactor, 1 meter cube? So wide range of solid waste we can utilize in this ABBR one, like industrial sludge, agriculture, terrestrial one. So waste normally in that 10 meter cube, we'll be able to feed 300 to 400 kg of waste. Daily biogas generation is 4 to 6 meter cube per day. And is good for power production also. We have the, this is small generator, generating good amount of power here. So this is the, in that reactor, substrate conditioning and feeding. This is how the PBR hybrid generator of 5.2 kilowatt hour for power production. This is our patented reactor. In many places we are installing those reactors now. Until now, we didn't get any order of big reactors like 10 meter cube. But many places we installed 1 meter cube reactor in locally in Assam. This is our complete group, WMRG. We're working on different research area, including biogas, including compost, including and few research area in water treatment also. Yeah. Thank you. So we can have question answers now.
Thank you, sir. Participants, if you have any questions, please ask me. I have unmuted your microphone.
Good evening. This is Dr. Helena Sengupta from Techno India University, Kolkata. I have been into industry also. So another issue, like you were saying that there were so many challenges coming up. So another challenge is that though these different policies are being made, but the local authorities, like when you're making a housing complex and you are installing like windmills or panels on the rooftops, there is a requirement that the excess power be connected through a grid to the to the main grid. But I have faced this challenge that the the authorities are not aware what exactly is required to be done in most of the places.
So normally what I shared, I'm not accepting that big biogas reactor. So especially for power production, if you want to go for, I think the smaller reactor is better. For I personally believe that this 10 meter cube, we are generating good amount of power out of that. So 10 meter cube, 20 meter cube, 30 meter cube, this is the good enough for the any residential area. And small generator can generate good amount of power if you are going for power production. So that doesn't require any those connection and all. It's very easy actually.
No. I
Just
understand what you're saying. My point was different. Say I have like you're doing a big housing complex, maybe say 10 to 15 towers of maybe around say G plus 17, 18, those level things I'm saying. So over there, when you're wanting to install this renewable source of energies and you're doing it, then there's a requirement that whatever the production is has to be connected to the main grid. And so when we approached the local, electricity boards and other things, they were not aware what exactly is to be done. So that was a challenge which we had been facing.
So, but why you are connecting with the local bodies? Because local body they doesn't know. Local corporation, if you ask them to get connect, they don't do it that well. So someone is, I think, providing this facility. Like, if you ask me, like we can connect in the local wiring and all. You doesn't
Hmm.
require very specializing one. Like what we are doing in the laboratory right now, because our laboratory, the institute has provided the power to us, but whatever the generator we have created, I think is not very major challenge for to get connect into that. So easy connection could possible into that. And what you are sharing, that obviously the corporation or the local power unit, power providing authority, they are not aware about those things. So you need to connect with those people. I think those who are installing those biogas reactor, they'll be able to explain how to get connect or how to get connect with the local connections there with the biogas unit.
Okay. Thank you so much.
Yeah.
Participant, any question? Any other question? You may post your question in chat box also.
Sir, myself, Dr. Srivastav, Krishna Srivastav.
Yes, sir.
I would like to ask, what is the possibility of blending biogas with fossil fuel to use in the vehicles? Or is there sufficient feedstock to have this biogas to use in vehicles?
So vehicles are, I think, like if you have the biogas engine, doesn't have, I think, is there only gas unit only, not with the diesel and other. So mixing until now, I think we do not have information about that one. Like if you go for petrol, diesel along with the bio CNG.
In the
So
dual fuel, we are using LPG direct as well as hydrogen. We are using in dual fuel mode. It is in research process with the GDS engine. Is there any possibility for like this?
hydrogen, I'm not aware about the hydrogen one, but if you think about cooking fuel, so cooking fuel there is no problem, sir. Directly you can connect with the cooking one. So LPG, I think many places where I'm personally my startup, we are providing to the local rural areas. So they removed the LPG cylinder now. They are no more. They are utilizing that, because they have the good amount of agriculture residue with them. And here water hyacinth is very common. Like in Odisha also, water hyacinth is major challenge. So they are feeding. They just only thing that they have to make the slurry. So for slurry making, we required one grinder. So if you grind, and water hyacinth easily can grind that with food waste and cow dung. If they mix any kind of composition, just feed it in the reactor, and directly that gas, whatever gas, without purification, we can use for the cooking purpose directly.
Okay, so it
Only
has,
moisture is the problem. Moisture is the problem, because with the gas, some moisture is coming out. We're asking them to, whatever the pipe they are connecting, just they have to have some removal facility for the extra moisture. Otherwise, I think they can utilize for directly for the cooking purpose.
thank
Any question? Participant, any question? Sir, another question: which software was used for LC analysis, sir? Which software was used for LC analysis?
राकेश सर, राकेश सर,
सर गुड आफ्टरनून, गुड इवनिंग सर।
कैसे है?
ठीक हूँ सर। और सर आपके वहाँ पे चल रहा है सब ठीक ठाक?
हाँ हाँ हाँ, गुड गुड। Anyone, I think from someone has, I think, mute.
Okay, okay.
Okay. Yeah.
So, on behalf of the organizing committee and the Department of Civil Engineering, we extend our sincere gratitude to Professor Ajay Kalandhar sir for delivering an exceptional and insightful and scholarly session. And the depth of your resource experience coupled with your clear and structured presentation has added significant value to this ATAL FDP. We deeply appreciate the time and commitment you dedicated to sharing your expertise with us. Your contribution has not only enhanced the quality of the program, but also inspired the attendees to pursue advanced and sustainable approach in the field of climate. Thank you once again, sir, for your distinguished presence and for offering such an enlightening and impactful session. Thank you, sir.
Thank you, Sarang. Thank you. I finish early so that I think
No, sir, no
it's a
problem.
evening time.
Good evening, sir. I have one question.
Okay.
Okay,
Still.
okay, okay.
Yeah.
Okay.
I am having the question, like, can we replace this kind of generation from we are now generating as a solar power or any other renewable energy resources?
Yes, obviously. I think solar power, see, we need not to compare with other these renewable energy sources. This actually biogas, why I was promoting rather than solar and wind, because here waste management is also another problem, or agri residue is another challenge. So it has a win-win connection, like especially for residential area, like I was proposing for the one particular apartment. If the apartment, because in the apartment or the particular society, if they can separate it out, this biogas, the waste material, especially the kitchen waste, they can directly feed into their digestive itself. And we can, if you can generate the power out of that, especially in the parking area, in that residential area, that is the best thing. So here two things we are taking care of. Waste management is also there, and parallelly we can work with the power production also out of that. If you are not looking for power production, because generator and those facility will be required, those could be costly. If you are able to generate cooking fuel also out of that, at least few households or at least that security people, they'll get the cooking facility. So your waste management also will be possible, and you are getting some benefit also out of that. So it is not competing with the solar or anything.
Okay, sir. Thank you so much.
Okay, thank you, sir.
Okay, then I think thank you everyone, and thank you,
Thank you,
Sujit sir, for invitation.
Thank you, sir.
Hope I think next time we'll come personally, physically, and
Okay, sir.
we'll-
Thank you, sir. We
Okay.
welcome.
everyone. Bye bye.
Bye, sir. Sir, stop presenting, sir. Okay. So, Rakesh sir, can we start?
Yes, sir.
Okay, sir. So today, now for day 1, session 2, the topic on air and water pollution mitigation measures and sustainable development will be presented by Professor Rakesh Roshan Das, sir. And he is now the professor and dean student welfare at Bir Surendra Sai University of Technology, Burla. He has obtained his MTech from IIT Delhi and PhD from IIT Roorkee, specializing in environmental science and engineering. His major research include water quality treatment, riverbank filtration, and wastewater management. Before joining academia, he has served as a scientist at the Bureau of Indian Standards, Government of India, for nearly 6 years, where he contributed significantly to national standardization initiatives in the environmental sector. He has been a committed faculty member at VSCC Burla for the past 13 years. He has extensive international exposure. He received the French government scholarship to pursue his MTech thesis at INCA France, and undertook a scientific research visit to the University of Applied Science, Germany, under the Economic Cross Cultural Program. He has successfully led sponsored research projects, including major studies on the environmental impact of fly ash from thermal power plants in Odisha, and the evaluation of water quality of riverbank infiltration system in Uttarakhand. These works were supported by organizations such as the State Pollution Control Board and the Uttarakhand Jal Sanstha. He has published numerous research papers in reputed international journals, has actively participated in many national and international conferences. Adding to his distinguished achievements, he has received an ISO sponsorship to attend the international workshop on water held in Japan in July 2012. It is indeed an honor to have Dr. Rajesh Roshan Das sir with us today. We look forward to his expert insights and an enriching session ahead. Thank you, sir. You may continue.
Okay, thank you. Yes, sir. Thank you for the nice introduction. As I have given the topic of air and water pollution, mitigation measures and sustainable development. So mostly we are talking about different types of pollution that is occurring in air as well as water. Mitigation measures means what are the things we can do about the pollution, how can we reduce the pollution, and the sustainable development. I think I am audible.
Yes, sir, you are audible.
Okay. So these are the contents of my presentation. So firstly, we'll start with the water pollution and resource management, where we include actually most of the things are mostly theoretical approach. So one topic which may you like, that is riverbank filtration. That is another thing which is under water pollution and resource management is rainwater harvesting. In the air pollution mitigation measures, we are going to discuss about the global warming, climate change, clean development mechanism, that is CDM, sustainable development, and green buildings. So we will start with water pollution and resource management. So first we will have a look about our water and wastewater scenario. So as you know, with the increase in the population, the available water is decreasing. So water is vital to the existence of all the living organisms, but this valued resource is increasingly being threatened as human population grow. Okay, so with different environmental challenges in India, freshwater scarcity ranks very high. So with time, the fresh water means what is the available for drinking and day-to-day household work, the scarcity is increasing day by day. So that is the major scenario in the current case. So urbanization has encouraged the migration of the people from villages to urban areas. So another aspect is due to the urbanization, due to lack of facilities in the villages, the people are migrating from villages to urban areas, which is actually shifting the availability of the water in different areas. So this is actually a picture taken from a website, Comprehensive Assessment of Water Management Agriculture. It is a 2007 photograph. So you can see in the picture there is a dark red color, that is, you can see this economical water scarcity. Then this is red color, blood red, that is physical water scarcity. Then this is orange color, approaching physical water scarcity. In this blue line, this is little or no water scarcity, and this white color, it is not estimated. So you can see India, most of the part of India are under physical water scarcity. Generally, you can see the South India part. In the middle India, central India, it is approaching physical water scarcity. And in the northeast and the north part, it is economic water scarcity. So what is exactly physical water scarcity means we are really facing the water scarcity in that area. So there is a shortage of water in those areas, that is physical water scarcity. Orange color mark is approaching physical water scarcity, means maybe after few days or few years, the area is going to be in the physical water scarcity zone. Economic water scarcity, that is one important aspect for Indian point of view, because in those areas we have water, but we don't have the facility to tap those water or to utilize those water. So that is economic water scarcity area. Little and no water scarcity means there is sufficient quantity of water and we have the facility to tap them and use them. So you can see India is struggling, means the availability of water is very, we can say it is under scarcity in India. So scenario of water and wastewater, it is continuing. Water scarcity is a function not only for volumetric supply, but also for quality sufficient to meet the demand. So as well as we need quantity of water, we need better quality of water. So we need both quality and quantity for our day-to-day use of water. So drinking water demand is perhaps the largest demand for higher quality water, apart from many industrial use, which also require high quality water. So we know that different qualities of water is required for domestic use, different qualities of water are required for industrial use. We have different standards for that. We have IS 10500, that is drinking water standards for our drinking water. So also for different industry use, we have different water quality standards. So agriculture by far is the largest consumer of water, also suffers when water supplies become saline. Agriculture also use a large quantities of water, but we are going to suffer when the water used for the agriculture, it becomes saline or salty. Salty saline case is taking place because of the intrusion of the seawater into the aquifer. So that is a major concern nowadays because of the coastal areas, the increase in the population in the coastal areas and use of the groundwater in the coastal areas force the seawater intrusion, and which causes the groundwater to be saline. So as we know, distribution of earth water, we can see that 97% are saline water, fresh water is 3%. In that 3%, we have very less actually water that can be used. You can say river water is 2%, lake water is 87%, swamp water is 11%. So from the surface water, the amount is river water is very less, where lake water is much more higher. I think I'll skip the things. So if we come to different types of pollutants in the water, maybe some are all are acquainted with the environmental pollution with the water. So you can see we have different types of pollutants like infectious agents, which are microorganisms like bacteria, virus, protozoa, parasitomes. Oxygen demanding waste like organic waste. Sir is talking about different organic waste and formation of biogas. So those organic waste are which can be degraded biologically. So organic waste, oxygen demanding waste, those are organic waste. Similarly, we have inorganic chemicals like acid, metal, salt. Those are inorganic chemicals. Radioactive materials also, the radioactive iodine, radon, uranium, cesium, thorium. Plant nutrients like nitrate, phosphate. Organic chemicals like oil, gasoline, plastic, etc. Eroded sediment like soil silt, heat, thermal pollution. So these are the major categories of water pollutants. So as an environmental knowledge person, or we are studying the environmental, so we have to remember 2-3 things like river water generally contains a large amount of suspended solids and microorganisms, where groundwater contains large amount of dissolved solids. So these are the major concerns. Sometimes the groundwater also contains some heavy metals. Okay. So these are the major concerns as a public health engineer or as a water treatment engineer or a environmental engineer. So you have to concern about different types of pollutant. So we have to so this is you can see pollution in a stream. So in the pollution in a stream means when the wastewater is coming from the industry, when it is taken into or it is disposed into a river or a stream, what is generally taking place inside the stream. So in the river, when it is generally disposed of in the stream, initially you can see the first phase, the phase 1. This is the clean zone. So here the wastewater is disposed. So this is the clean zone. normal clean water organisms. The sufficient amount of aquatic life are moving. Next zone is the decomposition zone. Generally, our industrial wastewater contain large amount of organic waste. So we have talked about the organic waste. That is in terms of BOD, COD, total organic compound, carbon compound. So those general things are decomposed in this zone. So in this zone, you can see very less amount of aquatic life because active decomposition starts there. In the third zone, that is septic zone. Septic zones means the oxygen present in the water generally degrades. Okay, so generally in the saturated condition, water, your river water contain 9.2 milligram liter of dissolved oxygen. When the dissolved oxygen reduce below 4, generally aquatic life fish generally they die because of the shortage of oxygen in the water. So in this septic zone condition, the oxygen decreases, and it decreases sometimes goes nearer to zero value. So there is no oxygen. So this is condition is septic zone, and the condition is anaerobic condition. Anaerobic means there is no oxygen present there. So whatever the degradation taking place because of presence of some bacteria, those bacteria don't need any oxygen. So those are called anaerobic bacteria. So this is septic zone. Actually, that is the difficult part of a stream, the septic zone. The fourth zone, recovery zone, is similar to decomposition zone. So it is in the recovery zone. Some of the oxygen it get back, the water get back some of the oxygen. So DO value again increases, and some of the aquatic life again survive. Okay, the last zone is the clean zone, similar to first zone. So in this case, the dissolved oxygen in the water generally increase to its normal value, and most of the aquatic life survive in this zone. So these things are important because when wastewater is disposed into the river or stream, this generally takes place. And when we are talking about the water supply and all these things, we have to take the water generally from the upstream and from the clean zone. If you are going to take the water for drinking from the septic zone or decomposition zone, there is a lot of problem or a lot of water pollutants in the water. So lake pollution, you may be aware about the lake pollution. So generally there is lake pollution. I'll just going a little bit faster. Only oligotrophic lake and eutrophic lake. So oligotrophic lake is there where there is no algae, okay, or any what you call less nutrient is there. So when lake or pond, you may be knowing that lake or pond are stagnant water. The water is not moving. In the case of river, you can see the DO is decreasing, then increasing. But in the lake or pond, there is a difficulty because there is no flowing water. The water is stagnant. So when nutrients like nitrogen, phosphorus enter into the lake, the algal growth will be there. Algal growth you can see in these green patches are there. When there is algal growth, the sunlight cannot penetrate through the top layer, and the anaerobic condition will prevail in the bottom layer. Okay, with the depth, the anaerobic condition will prevail. Then when anaerobic condition prevails, the methane gas will be produced. So the people staying at Bhubaneswar may be aware there is a Bindu Sagar near to the Lingaraj temple. So always methane gas is coming out from this lake. So these lakes are lake or pond. So those are eutrophic lake. And oligotrophic lake means there is no nutrients and there is no algae growth. So we have talked about the river pollution. We have talked about the lake pollution. Next is the groundwater pollution. So we have different sources of groundwater pollution. Slow flowing, slow dilution, dispersion. Whenever the groundwater is polluted, unlike river water, the groundwater moves very slowly. So the dispersion of the pollutants is very slow. So that is the difficult part because when the dispersion or dilution is very slow, the pollutant will take time to disperse. So the pollutant presence in the groundwater will be there after some distance or after some days also, because the dispersion dilution is very slow. And another thing is the groundwater contains generally zero dissolved oxygen or very less dissolved oxygen. So because of the presence of very less dissolved oxygen, whenever the groundwater is polluted with the organic pollutant, so it cannot be degraded by the aerobic bacteria, okay, because there is no oxygen. And when it is polluted with some organic matter, so degradation of the organic matter is very difficult. So whenever it is polluted with the organic matter, it will be present in the groundwater. So it is a tricky situation when groundwater is polluted with the organic waste. Cooler temperatures slow down chemical reactions. So because the generally groundwater have a lower temperature in comparison to the surface water, so the degradation, whatever the degradation takes place, it becomes slow. Because for the higher the faster degradation, we need higher temperature up to some degree. Generally, the degradation is very good between 20 to 60 degree centigrade. So because generally the water temperature in the groundwater is less than 20 degree, it is below 15 degrees. So the degradation will be also very slow. So I am going to skip this. We have already discussed ocean pollution because of use of different what you will call vehicles in the ocean. The oil spillage will be there, as well as dumping of different waste into the sea. It causes the ocean pollution, and it causes the coastal water pollution. I am going a little bit fast because it has a lot of slides. So next we are coming to, we have discussed about the surface water pollution. We have discussed about the lake pollution. We have discussed about the ground pollution. We have discussed about the water pollution, ocean pollution. So why we are studying about the pollution? As an environmental engineer, only we should not be studying the pollution. We have to have some mitigation measures, and some measures to reduce the pollution, or to you can use the water in different way. Okay. So you can see water problem in many parts of the country is well known. Unplanned or rampant groundwater exploitation has resulted in lowering of water table in rural as well as urban areas. So because of use of groundwater in the villages as well as in the town, we are using whatever the groundwater recharge is very slow, but in comparison to the recharge, we are utilizing lot of groundwater. So because of which you can you may have gone through the articles that the groundwater table in the Delhi or some major metro cities has gone down. So because of which, whenever you are digging a well, the water, you are going to get the water at a very higher depth. So groundwater depletion is a natural and it is a constant problem in our country. So groundwater in a basin is not in a state of rest, but it is dynamic in nature, in a state of continuous movement. Groundwater, which once thought as steady source of water, is now more a reliable source due to faster lowering of the water table. Previously, everyone is using the groundwater, but now the government have put some objection to it. They have to use get the permission to use the groundwater, but also that is violated by many people. Hence, there is absolute need to augment conservation of water and recharging of the groundwater. So now the time has come to recharge the groundwater. That is one of the important aspect of using groundwater. So water conservation and harvesting. So the time has come to conserve the water and go for rainwater harvesting. So we'll start with a technique that is an ancient technique, but used now with time, so that it can be just a minute. Okay. So this technique is called river bank filtration. Okay. So I am going to talk about this topic a little bit more, because it is interesting topic maybe for few of you. So you may be aware of this type of hole, or a you can see people are dug some holes near the river bank. This type of holes are there in our south part of Odisha as well as in Andhra Pradesh, in some part of other areas. So what the village people are doing, they are generally digging a hole near the bank of the river in the evening time, and they are getting the filtered water in the morning time. Okay. So generally in Odia that is called chua. Chua, that is called Odia, it is called chua. In some villages they are using this practice. In this practice, what they are getting, when they are digging a well in the evening time, the water from the river percolates to that hole because of difference in the water head difference. The water is percolating inside the this hole, and during this percolation, the water gets filtered out. Whatever the pollutants and contaminants are there in the surface water, they get filtered out. And in the morning time, the village people are getting a filtered water. Okay. So this is the basic technique they are using. Some more photographs are there. You can have a look. So when this type of things are there, and when we are using this engineering system to this basic concept of water collection through those villages, that is called river bank filtration. Okay. So we are using the term bank filtration. It is generally called river bank filtration. If it is used in the bank of lake, then it is called lake bank filtration. So if we go by the definition, bank filtered water is surface water seeping from the bank or bed of a river or lake to the production well. So here another term is coming, what is production well? So any dog well, when we are digging a well nearer to the river, for the village people it is a small well. For the actually in the field it is generally maybe of width of maybe 3 to 10 meter, depth of maybe 10 to 25 meter. So generally we generally dig a well nearer to river or lake. So the surface water can seep from bank and bed into the production well. Okay. So during its groundwater passage, the water quality parameters change due to microbial and physical process and by the mixing with the groundwater. So when the river water or the water from the river or lake is passing through the ground, the water quality changes. Generally, whatever the pollutants and contaminants are there, they generally filtered out, and some other processes are generally taking place, and we are getting a better quality of water. As well as when water is passing into the well, it is mixed with the groundwater. So both the things are taking place. We are getting a good quality of water as well as groundwater mixing is there. So that is groundwater recharge is also taking place. So this process of bank filtration is initiated by lowering of a groundwater table below that of an adjoining surface water table. When we are having a production well or we have a dog well near the river and we are pumping the water from the dog well. So there is a depression in the water level in the dog well, and because of the depression there is a head difference between the river water level as well as in the dog well. So because of the head difference, the river water will infiltrate into the dog well because of this head difference. So when there is no artificial or natural barriers exist, the difference in the water levels cause the surface water to infiltrate through the permeable riverbed and bank into the aquifer. The infiltration may be direct result of an influent river under natural conditions, or it may be induced by the groundwater extraction wells. So generally, when we are extracting the water because of the hydraulic difference, it will infiltrate into the dog well, or sometimes even directly because of the natural process. Generally, during the rainy season, the river water level will be higher. So there is a difference of level or hydraulic level in the river water and a groundwater. So automatically during the rainy season, the river water will infiltrate into the groundwater. That is a common phenomenon. And generally reverse happen during the summer. Generally what happens in the summer, naturally the groundwater infiltrates into the river sometimes. So this is a schematic diagram. It may better in this picture you can better understand it. So this is the river. You can have a look. This is the river. This is our hole. This is our well. This is maybe bore well or production well, whatever you can, infiltration well, whatever the term you can use. So when pumping is done, this is the groundwater table. This line is groundwater table. So when pumping is done, the water will depress, the water level will goes down. So because of which there will be a hydraulic gradient created and water will pass through this aquifer. So when the water will pass through this aquifer, filtration, biodegradation, adsorption, chemical precipitation, and redox reaction. These are the basic process that will take place during this flow into the well. So because of this reaction, the water get purified. Okay. So what are the advantages of this riverbank filtration? So it is very natural treatment process because we are not using any filter media. Only our aquifer acts as a filter media. Improves the microbiological quality of water. Microbiological quality means it can reduce the bacteria, virus to some extent, protozoa, other things. Minimal need of additional chemicals like disinfectant, coagulants to surface water to control pathogens. So we need very less amount. Generally, when we are using riverbank filtration type of thing, generally we disinfect the water and supply to the population. It is effective in aerobic and anaerobic condition. In both condition, in presence of oxygen, in absence of oxygen, it can be used. Can be easily integrated with existing technology. If we have a water treatment plant, it can be also used as a pre-treatment option. So your the cost of water treatment plant will be less. Require little maintenance and easy to operate. So it will be very easy things. Decreased cost to the community without increased risk to the human health. So these are the some of the advantages of this system. What are the limitations? Because every system has both advantages and limitations. So some of the limitations are danger of over pumping. So if we are going for over pumping, the water level in the your dog well or in the production well goes below, and it will create a vacuum like thing. So the water coming from the river will not actually, there will not be flow, will not be continuous. So to maintain the steady state, the pumping should be done. That is, the rate of pumping should be equal to whatever the water induced into the aquifer. So otherwise over pumping will create the unsteady state, which will create other problems. Potential clogging of the bank filter interface. Sometimes when this aquifer is used again and again for filtration, whatever the pollutants in the river water is there, they will be clogged inside the aquifer material, because of which the clogging of this aquifer takes place after some years. Gradual reduction in the production capacity due to clogging. Because of this clogging, initially when water is this type of well we are getting 2 mld or 3 mld of water, then after some time it will reduce to half. Then what to do in those cases? You have to stop the operation of those filter for 1 or 2 years. Then you can use again. Okay, for those 1 or 2 years you can have another well, and you can use other well. Okay, so you have to have series of well to get the water throughout the year, and maybe for 30-40 years continuously. So it may also cause potential aquifer pollution, because surface water generally contains a large amount of pollutant. So whenever it is entering into the groundwater, it may increase the aquifer pollution. These are some of the limitations. What are some of the parameters that is affecting the performance, like source water quality, geohydrologic condition of the aquifer, river aquifer interface, hydraulic gradient, infiltration rate, hydraulic conductivity, distance between riverbank and pumping. So those are the very important aspect of this riverbank filtration. Source water quality means what is your quality of river water. Okay, if the river water is heavily polluted, so you will get the filtered water not of that good quality. Okay, because your river water is initially heavily polluted. Similarly, geohydrologic conditions. Geohydrologic conditions means what is the soil properties of your aquifer, like what is the effective size of the aquifer, what is the D10 value, what is the uniformity coefficient of your aquifer, what is the coefficient of permeability of the aquifer. So these are the things which affect also the quality of the filtered water. River aquifer interference, that is similar to your geohydrologic condition. hydraulic gradient. Hydraulic gradient is the difference between the head difference between the water table in the your production well and in the river water. So if there is a higher hydraulic gradient, the water will percolate very fast. If the hydraulic gradient is very less, the water will percolate very slowly. Infiltration rate, that is dependent upon the hydraulic gradient. If the infiltration rate is very high, the removal of pollutant will be very less. If the infiltration rate is very slow, the removal rate will be high. So these are the factors that is affecting the performance. Hydraulic conductivity, if the hydraulic conductivity is high, the infiltration rate will be high and the removal rate will be less. So these are some of the basic things that are affecting the performance. So we have different types of well. Generally, we have horizontal collector well. These are some of the horizontal collector well. These are some vertical well. We'll have more pictures on this. These are some of the typical vertical well. You can see this is the river. This is the pumping tower. We are pumping the water. This is your vertical well. So when we are pumping water, river water is passing into the vertical well. Okay, this is generally a place like in the bank of the river. Some of our horizontal well, you can have radials in the well, laterals. So water is coming and it is infiltrating through the laterals of the well. You can see this is the main chamber of the well, and these are the laterals. Okay, so water is from the river water. It is coming inside the laterals and coming into the main part of the well. So you must be thinking maybe why it has been taught or why it is nowadays used. So it is used in USA. You can see that is at the Ohio River. You can see Ohio River. Here they are using a horizontal well. Horizontal well means they have these laterals. And so they have 7 laterals. So that is constructed on the Ohio River. Generally 6.1 meter diameter. This diameter is 6.1. 12.2 meter deep. So these are used in USA. Also Germany, they are also using. This is a place called Dusseldorf in Germany. So you can see these are the wells. Actually, these are the vertical filter wells. These are the vertical filter wells, and it is constructed nearer to the river Rhine. So these are used in Germany. You can see this riverbank filtration, 50% of the supply in the Slovak Republic is from this riverbank filtration. 45% in Hungary is from riverbank filtration. 16% of the water supplied in Germany through riverbank filtration, and 5% in Netherlands through riverbank filtration. So this is a tried and tested water supply scheme in some of the European as well as in USA. USA, another well is there. Another well at Canas. So in the worldwide, what is the result we have got? Okay, so this type of well, what is the result we have got? You can see virus removal is up to 8 log. 8 log means 10 to the power 8 times removal of virus. 8 log means removal of 10 to the power 8 times removal. Similarly, bacteria, protozoa, algae can be removed. Reduce biological regrowth potential more than 60%. Natural organic matter disinfection byproduct more than 50% removal. Total organic carbon, dissolved organic carbon 35 to 67%. That is organic content. Disinfection byproduct potential 53 to 82%, 47 to 80%. So these are the most of the things that is found from the research on this riverbank filtration worldwide. So whether it is available in India, yes. So this riverbank filtration is also available in India, mostly in the northern India. So if you have visited Nainital, the Nainital is getting the supply of this water through this lake bank filtration only. Okay. So when I have studied, we have these 7 tube wells are there at Nainital, which is getting the water from this lake by this lake bank filtration. Okay. So during our study, they have both tube well as well as conventional water treatment plant. But after the study, they have stopped the conventional water treatment plant. Conventional water treatment plants means screening, sedimentation, filtration. They have stopped those systems. They have only dependent now on the lake bank filtered water. After getting the water, they are disinfecting the water. Then they are supplying it to the people. So at Nainital, this system is in place. This is also in place at Haridwar. If you have visited Haridwar, that is in Uttarakhand also. Nainital is also in Uttarakhand. Haridwar is in Uttarakhand. So there also they are using infiltration wells. In the lake bank filtration at Nainital, they are using tube wells nearer to the lake bank. In the Haridwar, they are using infiltration wells. The infiltration wells are of diameter 10 meter. This is the diameter of 10 meter. With depth varies from 3 to 10 meter depending upon different places. So generally 16 infiltration wells are there. So they are getting this infiltration wells, they are getting the water through these infiltration wells and Haridwar and supplying to different hotels, different restaurants as well as to the consumers. Another type of this type of system is called infiltration gallery. This infiltration gallery is used at Dehradun, but it is a small scale unit. So here the infiltration gallery of rectangular unit is constructed at a river, and the river water is passed through the bottom and it is collected and supplied to the people. So this is the picture of this infiltration gallery. Another system in the Uttarakhand they have used, that is Uttaranchal Coup. So these are placed in the stream of the different bed, a different stream bed. Generally, this type of Uttarakhand Coup are used in the stream bed, and it is also getting the water percolated through the aquifer. Some of the this is a typical Uttaranchal Coup. This is device to collect the riverbank filtered water. These are the installation. Some of the photos are there. So some horizontal wells are used at Mathura. These are radial collector well. Some of the results I am showing, maybe those are aware about the environmental engineering, what is total coliform, fecal coliform, turbidity, UV absorbance, COD. For them, it is easy to understand the things. Like total coliform, which generally represents the presence of bacteria in the water. So this type of infiltration well in the Haridwar, as well tube well in the Nainital, infiltration gallery at Dehradun, Uttaranchal Coup at different parts of the Uttaranchal. You can see total coliform removal is very good. Okay, so in infiltration well, tube well and infiltration gallery, it is more than 90%. Fecal coliform, that is also show the presence of E. coli, that is fecal coliform. Also the removal is very high here. Turbidity removal is very high. UV absorbance, that is a measurement for the organic compounds. What is the organic compound presence? That is UV absorbance. So that removal is also very high. COD removal, some of the well, it is not found in the surface water or the source water, but whenever it is found in the lake water, it is the COD value was found. But in the filtered water, this is very less. So removal is nearly 96 to 98%. Similarly for the infiltration gallery. So as you say, this type of systems are very much what you can say that is very much useful, and it is a very cheaper method of getting the filtered water. Whether it is available in Odisha, yes. So bank filtration at Odisha. So maybe it may be available in other parts. In my study, what I have found that it is available at river Rishikilya, river Kharla. River Rishikilya is near Berhampur. River Kharla is nearer to my area, our Burla. It is in Kuchinda, and River Tail, it is nearer to Bolangir. So here also this riverbank filtration process is taking place. So in this Rishikilya, that is in the area that is called Bada Madhavpur in the Ganjam area. Generally 3 bore wells are used there. It is called production well. So it has a depth of 30 meter and diameter of nearly 5 meter. Okay. So you can see this system is used from 1983. So the riverbank filtration system is in Odisha. From my knowledge, is from 1983. So it is used more than 42 years back. Okay. So these production wells are getting water from the river Rishikelia through the aquifer, and it is supplied to the population of nearby Badamadapur. Similarly, the second place is at Kuchinda. It is used at Kharla River. There are also 3 production wells are there from 2010. Next is the Tel River, that is near the Balangir area. So there is 1 production well. So 3 sites I have found. Maybe more is there in Odisha. We have to capture and see what are their performance. So you can see this is river Rishikelia. This is river Rishikelia. So this is the production well at river Rishikelia. It is nearer to the Berhampur. This is river Kharla. So this is a production well nearer to the river. You can see the production. It's a big production well. So water is coming into this production well. This is on river Tel. Okay, this is a small production well. So what are the major findings from these field studies? We have found that whatever the turbidity, organics, coliforms or bacteria is there in the river water, it generally filtered out when it is passing through the aquifer. Okay. But during passage, the total dissolved solid, generally total dissolved solid means presence of calcium, magnesium, iron, sodium, potassium, sulfate, nitrate, all these things. Generally, the total dissolved solid value is increasing during passage, because generally when it is passing through the aquifer, some leaching process is taking place, as well as when it is mixing with the groundwater, because groundwater having higher TDS value. So when there is a mix up with the groundwater, the TDS value is increasing, but whatever the pollutant, it is decreasing. So these are some of the aspect of riverbank filtration. Next is rainwater harvesting. I think I will just just skip it. You may be aware of rainwater harvesting. So rainwater harvesting is another type of artificial recharge. What we do in the rainwater harvesting, we collect the rainwater that is in our roof or maybe in the surface runoff water. We collect the rainwater, then we recharge it with the groundwater. Okay. So generally the components of rainwater harvesting: collection, transportation, filtration, storage, treatment, distribution. These are a typical working method of rainwater harvesting. You can see here we are collecting the water. The pipes are there. We are collecting the water. Then it is passing through a filtration tank. Then the outlet. Then it is into the dog well. So because of which there is a recharge of the groundwater. So these are some of the methods. Next, coming to the air pollution mitigation. I'll skip. Maybe you are from there, maybe 6 or 6:30. So it is already going to 9. So I am skipping, just to have a look that different air pollution is there: anthropogenic sources, natural sources. These are some of the effect of the air pollutants, because of which we have global warming. Global warming means increase of Earth's temperature. Global warming is due to presence of greenhouse gases and excessive land use, excessive use of fertilizers, forest fire, aerosols, waste disposal, anthropogenic effect. Causes are like emission of greenhouse gases. So greenhouse gases, generally we talk about greenhouse gases. 6 major greenhouse gases are there: carbon dioxide, N2O, nitrogen, dinitrogen oxide, methane, chlorofluorocarbon, H2O. The water droplets are also greenhouse gases. You may be aware that people are telling about the carbon dioxide is not a what you call is a greenhouse gas, because of which global warming is taking place. But if carbon dioxide will not be there, then instead of global warming, global cooling will take place. Okay, so that is another aspect. So carbon dioxide is required in our atmosphere, but it should not cross some limit. Okay, so that is one aspect I just want to inform you. So you must be aware about the greenhouse gas effect and all these things. The carbon dioxide gas is one of the things. Next thing is the methane gas, that is 25 times more potent than the carbon dioxide. Okay. Next is nitrous oxide, that is more potent, 230 times more means dangerous than carbon dioxide. Similarly, chlorofluorocarbon, that is coming out from the ACs and free refrigerators. So it is nearly 1500 to 7000 times much heater than carbon dioxide. So these are the some effect of global warming, rise of temperature, effect on the weather like increasing precipitation, but the effect on storms are less clear. Extreme weather, drought, flooding, severe storms, severe winter, tropical cyclone, extratropical cyclone, wildfires, extreme heat waves. So these are some of the impact of global warming. Glacier retreat and disappearance. You can see in the picture, retreat of Gangotri Glacier, retreat of Mount Kilimanjaro. So with the global warming, the glacier is disappearing. The effect of ocean acidification will take place due to this global warming. Some of the impacts are there. I just want to skip. Animals, birds at risk. Animal, birds at risk. Regional impact. So what can be done? We have to measure. We have to have some mitigation measures like laws to limit the amount of pollutants produced by the factories. Using renewable fuels like solar energy, wind energy, replace fossil fuels with the renewable fuels, carry out energy saving scheme, using public transport, more plant, more greenery. With this, I am stopping. Okay. It is a very long slide. So I just want to stop with this, start thinking green. And I acknowledge my BCCT, IIT Roorkee, IIT Bhubaneswar, U India River and Filtration, Uttaranchal Jal Sansthan, AICT. Thanks for the kind attention. If you have any question, I would like to attend the questions.
Thank you, sir. Participants, any question? Sir. Dear participant, any question? I have unmuted all. So if you have any question, please ask.
Good evening, sir.
Good evening.
Sir, this is Karthikeyan from Tamil Nadu.
Yes, sir.
Sir, I'm having one general question related to underground water, sir.
Yes, sir.
Sir, actually, my area, locality I'm living is previously a leather factory was located nearby.
Okay.
Water is more salty and more.
Water
Sir,
is
there
more salty and
more corrosive, corroding.
okay.
Water taps corroding very soon.
Okay, so the water taps is corroding means whether it is white color corrosion or red color corrosion.
Sir, greenish and white color corrosion, sir.
Okay, white color corrosion means it is the precipitation of calcium carbonate that is due to presence of hardness in the water. Okay.
Okay.
If it is red color corrosion, it is due to presence of iron and manganese in the groundwater. Okay.
Okay, sir. Okay.
If it is salty, then maybe some seawater intrusion is there. If it is the taste is particle not salty, if it is in Odia we call khara. So if it is some other taste, it may be due to presence of calcium and magnesium. Okay.
Okay, sir.
Okay.
Sir, is there any health issue if we continuously using these kind of waters in our
Yeah,
lifestyle?
okay, actually, what happens? The total dissolved solute value that is prescribed by Bureau of Indian Standard as per IS 10500 is 500 milligram per liter, and it may goes up to 2000 milligram per liter. Okay, so you have to
Okay.
check if it is if TDS value is less than 500 milligram per liter, then it is okay. Okay.
Okay, sir.
Actually, I just want to tell one thing here because people, most of the people are listening here. Whenever you are buying a water purifier for your house, don't buy RO filters. If your TDS value is less than 300, don't buy RO filters. You generally go by normal ultrafiltration and UV, UF and UV. That is enough. If you have TDS value more than 300, then you can go for RO. What people are now telling, you buy RO, there means to purchase the RO filter. Most of the companies are selling RO filters like anything. But we should avoid buying RO filter. We should, if the TDS value is less, we should buy normal ultrafiltration and UV filter. Otherwise, the RO filter will make the water into the distilled water. It will convert the normal water to distilled water. If the TDS values goes below 50, it will have some health hazard. That is another aspect.
Okay, sir. Okay. Sir, thank you, sir. Thank you for clarifying, sir.
Any question? Mr. Onish Naik.
Yes, sir. Yes,
Uh-huh.
sir.
Okay. Rakesh sir, can you show your video actually? Video
Yes,
is
sir.
not on.
So may I ask?
Yes, sir.
Yes,
Yes,
yes.
madam.
Yes, sir. One of my students just sent me a report, a water report. They have just borewell and borewell water report that shows the nitrate value 45 mg per liter, but the standard value is 10 mg per liter. And one more thing regarding TDS. The TDS. Hello.
Yes, yes.
Yes, yes.
Hi, yes. TDS value that is greater than, I guess, 1000 ppm. So that I have suggested that you must have RO because of 1100 ppm. But regarding nitrate, I absolutely have no idea what to do because it is very harmful to infant as far as I know.
Yes, actually nitrate value 45 generally, what I remember as per IS 10500, nitrate value up to 45 milligram per liter is safe.
Okay.
What I am remembering, if the nitrate value is higher in your
Groundwater.
groundwater, it is better go for RO. Okay, because nitrate is a dissolved substance, you cannot be removed by normal filtration. It is better to go for RO. Okay.
Okay, sir. Thank you.
Any other question? Niranjan, Mr. Niranjan Behra. Have you any?
Good evening, sir. I
Good
am
evening.
Niranjan Behra. I am working as senior design engineer in L&T. I have one query. Sir, you are showing that river filtration with natural process.
Yeah.
And in nowadays, generally we go for the intake structure with some WTP plant. Which one
Yes.
will be cheaper?
Okay, actually intake structure is for conventional water treatment plant. Intake structure is generally to collect the river water without filtration in the aquifer. Okay. So if you are going for a conventional water treatment plant, first we have to have an intake. Then you generally we build a screen inside the intake. Generally it is taken to the water treatment plant where it will go for aeration, then sedimentation and coagulation, sedimentation, flocculation, then filtration, then disinfection. But in the riverbank filtration, we don't require any all this type of infrastructure. Only you have to have a production well or a dog well near the river. Okay, so it will act as an intake well, screening, sedimentation tank, filtration. Those four things can be done in a single unit. So that's why it is cheaper.
Sir, can we achieve our MLD?
It depends upon your permeability, coefficient permeability or hydraulic conductivity of the aquifer. If your aquifer having higher hydraulic conductivity, you may get. Otherwise, what you can do, you have to construct some more infiltration well near the river bank. Okay.
Okay. Okay. Thank you, sir.
Any question? Mr. Anish Naik, you may ask. Just unmute and ask.
Yes, sir.
Okay.
Sir, this is Bhagadhar Patra and MTech scholar. Sir, Odisha's industrial belt like Ongul and Talcher contribute both air emission and water emission. So, what sustainable technology can reduce pollution in both sectors together?
Okay. Frankly speaking, generally this type of pollution in terms of fluoride is coming to the surface water. Okay. And when they are discharging the, because of the fly ash, it is coming to the surface water. Groundwater is also polluted because of the fluoride and sometimes because of the chlorine and chromium and lead. Okay. So any solution cannot be done after it is coming to the air or to the your groundwater or to the surface water. Whatever done, it should be done by the industry. Like if they have the ESP, electrostatic precipitator, running for 24 hours, whenever there is a production of their product, then there will be less air pollution. They cannot stop the ESP. If they are going to use the ESP, so there will be less pollution in terms of fly ash and emission of the sulfur dioxide gas. Similarly, if they are using the proper liner when they are discharging their wastewater or they are discharging their slurry containing fly ash, if they will put a proper layer of liner and they will put the other things, then the groundwater pollution will be less. Okay, so in that way they can reduce the pollution. If groundwater is once polluted, then you don't have any other option, because the groundwater pollution it will take some time to reduce its pollution because of the slow nature of the mixing and dispersion. Okay, so if you are using the groundwater, you go for your treatment like house aquaguard or any water purifier, or similarly if you are using the surface water, you have to also go for some household water purification system. There is no other option. They can reduce only at the industry itself. And fluoride pollution is there generally because of these industries, fluoride and sulfur dioxide.
Okay, sir. Thank you.
Any question? Any other question?
Hello, sir. Hello.
Yes.
Yes.
Sir, I have a question, sir. Sir, what is the major barriers of implementing sustainable pollution control solution for industrial areas, such as particles, sir, PM10 and PM2.5? Sir.
Yes, I have already told you, because the particulate matter are coming from the what you call the exhaust. Okay, from the industries is when discharging their gases. Okay, so particle matters are coming from those exhaust. Okay, so they have to use some air control measures. Generally, they use ESP, electrostatic precipitator, that will reduce the particulate matter at the industry itself. Okay, generally in their exhaust or the gases coming out from the industry, it contains large amount of particulate matter in terms of fly ash. Okay, so they have to reduce by using ESP. Otherwise, it will come out, and you can see in the different leaves in the trees, the particulate matter generally accumulate. So they have to use the ESP properly. Okay, that is one thing. Or there is no other option.
Thank you, sir.
Any question? Any query? Any query from participants? I think that's okay. So thank you very much, sir, for your insightful and enlightening session. Your valuable expertise in environmental science and engineering, particularly your deep understanding of water quality, riverbank filtration, and sustainable water management has truly enriched today's FDP. Your presentation not only brought our technical knowledge, but also inspired all us to think more critically about the environmental challenge and innovative solution. We sincerely appreciate the time and effort you devoted to sharing your rich academic, research, and professional experience with us. So on behalf of the organizing committee, the Department of Civil Engineering, and all the participants, we express our heartfelt gratitude to you for delivering such a meaningful and impactful talk. Thank you once again, sir, for gracing this FDP with your presence and expertise. Thank you, sir. Okay, sir. Thank you, sir. So, dear participants, tomorrow we will join at sharp. Will be 2 sessions, and tomorrow we will join at sharp 6 p.m. Okay, with the same link. And for your kind information, daily feedback is not required. And at the end of the day, end of the FDP on 29th November 2025, we will provide the feedback link. Okay. Also, as well as you will. Okay. And for attendance, we are monitored through the Google Workspace. So, and tomorrow morning we will provide with that. And all of you have seen that attendance are already present in your auto login. Actually, as per the rule, they have presented all the participants, and according to your present or absent in the session, we will edit and let you know about whether you will be present or absent in that session. Okay. So thank you all. Thank you, participants.
Thank you, sir. Thank you.
Good night.
Thank you,
Good
sir.
night. If you have
Yes, sir.
any
Thank you.
query, you may post. You may call me. Or
Thank you, sir.
Thank you, sir.
you may send message to our WhatsApp group.
Thank you, sir.
Okay. Thank you. Sir. Thank you.
Thank you. Thank you, sir.
Okay. Thanks.